First, I tell you de Broglie's hypothesis. If a body be moving with a momentum P, the wave nature of that body will have a wavelength called de Broglie's wavelength, which is expressed under the formula lambda is equal to h by p. That is the de Broglie's hypothesis. But you can associate the concept of wave-particle duality. Wave can act as a particle, and particle under motion can act as a wave. Particle under motion can act as a wave that has been expressed here, lambda is equal to h by p. But if you take p here and lambda there, then that will become the momentum of the wave particle. For example, light. The particle of light is photon. That photon possesses a momentum that can be also expressed from here. For your term 2 exam, you have to keep this one in mind, very simple. This is the Planck constant. This is the momentum. This is the wavelength. If you are having the momentum, you can find the de Broglie's wavelength. If you are having the wavelength of a wave, you can find the momentum of the particle of that wave from the same formula. If you simplify it, if a body is moving with a velocity v, then momentum is m into v, which can be placed here. This is the simple momentum. In de Broglie's hypothesis, in solving questions, you have not to bother much. You have to use this only. Now, the simple formula lambda is equal to h by p has been expressed in different forms. For example, you are knowing the kinetic energy of the particle which is under motion. Then you can use this k is equal to half mv square. From there you are getting p is equal to under root 2 mk. In case the body is having kinetic energy k. Similarly, if an electron be moving and this be accelerated through a potential difference v, this is not velocity, this is potential difference through which the electron has been accelerated, then the energy associated with that electron will become k is equal to ev. This k can also be used. If you summarize all these formulae, you will get lambda is equal to h by p. Under hypothesis, you know that one. If you convert, simplify it, this is h by mb. Mainly question comes in simple format. Body of mass, this is moving with velocity, this. What is the de Broglie's wavelength? Or comparison. Two bodies are in motion. Now we have to compare their de Broglie's wavelengths. Their h will also cancel out. Simply lambda 1 by lambda 2 will become v1 by v2. Lambda 1 by lambda 2 will become v2 by v1. Inverse one. If you place p in terms of kinetic energy, you have this h by under root 2 mk. If you place this one in terms of potential difference through which the electron has been accelerated, then lambda is equal to h by under root 2 mev. If you solve it in NCERT, it has been directly given, but here the unit will be nanometer. Means if you calculate H to mass of electron E, it comes out to be 1.227 divided by root V. So you must keep this one. It is most probable this year.